Hi everyone, welcome back. In this video, I'm going to write a simple program that will illustrate a few key concepts in object-oriented programming using the C++ language. Namely, we'll look at inheritance and polymorphism. Okay? Inheritance is a practice within object-oriented programming where we can create a brand new class based off of another class. Right? So we can extend a base class and inside our child class have all the functionality from the parent class and add some additional functionality of our own. Okay, and then in the second part I'll show you how we can use polymorphism to treat all of the child classes as if they were the same class. Right? So we'll be able to put objects of different types inside the same array, for example, which up until this point, is impossible. Right? We can't mix integers and doubles and characters, for example, inside a single array. But with polymorphism and classes creating our own objects, we can. All right? So let's go ahead and get started with inheritance. Okay, so for this example, I'll write a few classes that are going to help us out and use those inside of our main. Okay, so I'll start off by writing our base class. Okay. And we'll call this class shape. Okay. So what I'm going to do is I'm going to have a base class that is a shape. Okay. And then the children, I'll make a couple children for it, like a triangle, maybe a circle, maybe a rectangle, etc. And those will all be classes that are or that have a relationship to shape. Right? A rectangle is a shape. A triangle is a shape, a circle is a shape. Okay? So in my base class, I'm going to have a name for the shape. Okay? So all classes, or all shapes, are going to have a name. Right? They have to be, a triangle or whatever, like I said. Okay? So every single class is going to have a name. Alright, and then I'm going to have a constructor for this. Let's see, shape, and we'll have a single argument for it, and this constructor will be responsible for assigning the name to this shape. Okay, so name equals s. Alright. Okay, and I'll just do it inline. I'll declare this function inline. Okay. But I'm going to also have a couple of getter and setter functions. Okay. Let's see here. Void set name. Okay, and this setter function is going to be responsible for setting the name of the function. Okay, so name equals s. Okay, and then we'll have a get function. Get name. Okay. And just all it's going to do is return the name of the function. Okay. And again, all these are going to be inline. Oops. Okay, there we go. All right. Then we're going to add a function a little later that's going to determine the area of the shape. Okay, but we'll hold off on that for now. Okay. So this is our base class. And right now, this private member variable name, it's private, so that means that the child class won't have access to it, and that's not going to work. Okay, oops, I forgot my public keyword in here. Okay. I want the I want all these functions to be public. So let's make sure that that's the case. Okay. But anyway, so right now, the string name is private by default. Right. That's not going to work because when I go to extend this class, I'm going to extend it and treat it as a private class. And if I do that, then I won't have access to my child class to string name. So we're going to change it to protected. Okay. So a protected variable inside of a class is treated just like a private variable in that base class, but once we have a child class, the protected is going to change. It's going to change depending on what we set the class access specifier to. Okay. So this is our base class, and we should be good to go. So let's just try to test it really quick to make sure everything works. So shape S, and we'll just call it foo. Okay. And let's run it, make sure it works. Oops. Oh boy, that should be a void function. I should have turned that string. There we go. All right, let's try it now. All right. So compile's fine. Let's try the get name function. Make sure that works too. All right, there we go. So that works. All right, so now let's create a child class. Okay, let's do the first child class. All right. So we'll make a circle. Okay, just to start off with. All right, so class circle. But in this case, it's we want to have our variables in here be private. It's totally fine, okay? Because we're not going to extend. We don't plan on extending the circle class itself, right? We're not going to have a child of the child. So let's put in a value for the radius of the circle. All right, and then let's make some public functions here. All right. So the only thing we're going to need right now is a constructor, because we're going to need a constructor, and we're also going to need getter and setter functions for this radius variable, but we're going to inherit the get name, set name functions, and we're also going to inherit this this string name variable here, so we don't have to write those again, okay? Because we're going to use the members that we inherit from the base class, okay? So how do we inherit that? How do we do it? Well, we use this colon here, and then we use a class access specifier. Okay, I'm going to make it public, and then we put the name of the class we want to inherit from. Okay, so circle is going to be a derived class that's derived from shape. This public access specifier here is going to cause this protected variable here to be private inside of the circle class. Okay? But we're going to now have access to this variable. We're going to have access to these functions plus the functions that I defined inside my circle class. Okay, so we're going to have a constructor in here. Okay, circle, and it's going to have actually two parameters. Okay, it's going to have a parameter to accept the name of the object, and it's also going to have a parameter for accepting the radius of the circle. Okay, so how do we assign the name to our class, right? We're going to have this name variable that we inherit, but how do we initialize it? Well, we're going to invoke the shapes constructor to help us do that. Okay, so this is how we do that. Okay, so what this is going to do is this is going to pass, this little syntax here is going to pass the value in n, which will be the name, and it's going to pass it to the constructor in the base class, and then that constructor is what's going to assign the name. Okay. All right, but we're still going to assign our radius in our own constructor. Okay, so radius equals r. All right. So let's write some getter and setter functions. So we'll write our mutator first, set radius, double R, okay, and this is going to say radius R, okay, alright, and then let's write our accessor, our accessor, okay, let's return double, get radius, right. And we need to call its keyword, because it doesn't change anything. Alright, and so this just returns the radius. Okay. Alright, so let's test that now. Okay, so let's create a circle object. Okay, we'll call it circle C. We're going to invoke the constructor. We're going to give it a name of circle, because that's what it is. It's circle. Okay, and then we'll give it a radius of 3. Okay, so what's going to happen is when this object is instantiated, the name circle is going to be passed, it's going to go into the constructor here, but then that's going to be passed to the shapes constructor, and then the name is going to be stored inside this variable. Okay, and then the second value, the radius, that's going to get stored inside stored inside the circle object, just like it normally would. Okay, so let's file this and test it. Okay, all right. So let's see if our inherited member functions work. C dot. See, we have get name and set name, right? I didn't write them for circle. We inherited them from the shape base class, from the parent class. Okay, C set name. Okay, and let's change it to circle 2. Okay, and C dot get radius. Okay. Just a couple little tests here to make sure everything works. All right. Oh, I should probably get the name to set it to show that it worked. C dot get name. Okay. All right, let's try it now. All right, so you see that? Pretty cool, right? I mean, I didn't have to rewrite these member functions inside the circle class. I inherited them from the base class. I already wrote them in here. I didn't have to rewrite them again because I took the base class, which was shape, and I extended its functionality. Okay, my derived class, also known as my child class, inherited the name plus the set name and get name functions. I didn't have to redo everything. All right, so let's make another child class. And this time we'll make a rectangle. All right, and it's going to inherit. It's going to be the child of shape, just like circle was, but it's going to have a couple different members. Okay, it's going to have a length and it's going to have a width. Okay, and it's going to have an interface, which is going to include a constructor. Okay, so we have rectangle. It's going to accept the name, it's going to accept the length, and it's going to accept the width. Okay? And then we're going to have to invoke the parent's constructor to pass up the name, just like we did with circle. Okay? And now let's write our code here to do the initialization. Length equals L, and width equals W. Alright, now let's write a couple getter and setter functions here. Finish off our interface. Alright, so void set length L. Oops. L. And we'll do a set width function. All right, so that should do it for our second child class. So let's test that. Okay, so let's go rectangle R, and we'll give it the name rectangle, and we'll give it a length and a width of 4.2 and 2.5, and whatever. Okay, and then we will see out its name. Name, right? The method or the function that we inherited from the shape class. Okay, and then we will see out its length. Let's see. Did I not write the? Oh, I forgot to write the accessors. I only wrote the mutators. Okay. Double get length. And then we'll write the mutator for the width. Alright. So now these guys should appear. R dot get width. There we go. And R dot get length. Alright, let's test it. What did I do? What did I do here? Oh, forgot my parentheses. There we go. Okay, that's ready. Oops. Alright, and I forgot an operator here. Alright, let's try that. Alright, there we go. Okay, so there's the name of the rectangle. There is the length and the width. Okay, so that looks good. Alright, so I think I will do one more shape here. I have a circle, I have a rectangle. How about we do a triangle? Okay, third child class. Okay, and we're going to set up the inheritance again. Public shape. Alright, and this is going to have a base and a width. Okay. And now time for our interface. Oops, I don't want to call it rectangle, I want to call it triangle. Triangle. Okay, so public triangle. Again, we're going to have a name that we're going to pass to the parent class. And then we're going to have a base and a width. Okay. Going to pass the name up to the shape class, the parent class. And then we're going to assign the base and the width. Okay. Change that auto feature that's fine. Okay. Alright, so I think I'll just to save time, I'll skip doing all of these getters and setter methods. I mean, we can see them. I already did examples in the previous two classes, so we'll just skip those for right now. Alright, so we'll skip those. Okay, so let's create a triangle. Triangle T. We have to give it a name of the shape. Okay. And then we're going to set the base and the height. So 4 and 3. Okay. Alright, so let's test it. Alright, so it compiles. Alright, so right now I have 3 different child classes that were all derived from one parent class. Okay, so you'll notice that we can use the parent class, but now we can also use all of the child classes as well. Alright, so that is an example of inheritance. Right? So what I'm going to show you next is an example of polymorphism. And and also kind of a component of inheritance as well. What I'm going to do is I'm going to write a function in the base class that we're going to use in all of the child classes as well, but we're going to utilize a concept or a feature of the language known as dynamic binding. Okay. So what we're going to do is we're going to write a get area function, double get area. Okay. And get area is going to compute the area of all of the shapes. Okay. But you'll notice here that my base class doesn't have any variables defined for dimensions of the shape, right? All it has is a name. So we're going to leave this, we're going to make this a virtual function. Okay, and we do that by assigning 0 to this getArea function. So this is now a virtual function. It's actually a pure virtual function because it's not going to have a definition. All it has is equals 0 to it. That means that this function is never going to be defined. It means this class can no longer be instantiated because this is now an abstract base class. Okay. An abstract base class just has members that define what the class is going to be, but it'll never actually become a real object. It'll never be instantiated. Okay. It's an abstract base class. It contains a pure virtual function. Okay. And so this virtual function, we're going to define it, we're going to redefine it in each one of these base classes. Okay? And then depending on which getArea function we call from which class is going to determine which one actually gets invoked. Right? So far up to this point, every single one of these child classes, when we've wanted to get the name or set the name, we've used the member functions that were in the base class. Well, when we redefine getArea in each of these child classes, then it's going to have the same name, but the function is going to be different, and it's going to be different depending on which class it's called from. Okay, so let's go ahead and do this. Okay, oops, I forgot. I need the word virtual here. It's a virtual function. Okay? The virtual is what makes it a virtual function, and the equals 0 is what makes it a pure virtual function. Okay? So right now, if I try to compile this, I should get an error message. Okay, bam, right here. Okay, why? We can't instantiate the shape anymore. Why? Because it's an abstract base class. And abstract base classes can never become objects. Okay, why is it an abstract base class? Because it has this pure virtual function inside it. Okay. If I was to define this getArea function like any other function, it would still be able to instantiate. But since it's a pure virtual function, it can't. Okay. So let's remove shape foo from here. Okay. Try it again. Oops. Oh, why are we? We're still not compiling. Why? Because when you have a pure virtual function in here, all of the child classes are inheriting it as well. So right now, they're all abstract base classes too, because they have inherited this pure virtual function. So in order to fix that, in order to take care of it, what we have to do is we have to define the function. We have to give the function a definition in each child class. Okay, so let's do that. Okay, so double. So we'll make these virtual too. Virtual double get area constant. Okay, so the area of a circle is was it pi r squared? So return 3.14159 times radius. Okay. So now this virtual function has a definition. It's no longer a pure virtual function. It should work. All right. So now let's define getArea. Oops. For the rectangle. Okay. Double getArea const, and it's virtual also. Okay. And let's turn length times width. Right? That's the area of a rectangle. Okay. All right. Now let's do the triangle. Return half times base times width. All right, so let's compile this now. See what happens. Okay, bam, compiles. Okay. All right, so now let's get the area of each of these shapes. C out C dot get area. Okay, that's going to find the area for our circle, and it's going to call this get area function because it's bound to a circle object. Right? That's what's when we talk about in lecture about dynamic versus static binding. Well, what's happening here, since this is a virtual function, the binding, this get area function, is bound to this object at runtime. Right? So when this code is executed, then that's when this get area function is assigned to a circle, So then this get area function is the one that's called. Not this one, not this one, not this one. Okay? Because if we don't do that, if we don't make this virtual, then how would the compiler know which get area function to call, right? Because we would be inheriting this get area function if it wasn't virtual. Okay? So when we call it is when the get area function is bound to the object. So that's how C++ knows, or which program knows which get area function to call. Okay? The one in the base class or the one in the derived class. All right, so r.getArea for a rectangle, and then t.getArea for our triangle. All right, so let's run it. So there we go. Oops. Okay. So there's the triangle's area, right? 4 times 3 divided by 2 is 6. There's the rectangle's area. 2.5 times 4.2 is 10.5. And then there's the circle area, right? 30.1907. All right, so now you know how to write a class, how to use inheritance to extend the base class, the functionality of the base class to the child classes. And now we can use dynamic binding to bind virtual functions to each of the child classes. So what about polymorphism? Well, this is an example of polymorphism using this getArea function I just showed you here. But we can use another feature of polymorphism to combine different objects and store them in the same array. How do we do that? Well, what we do is we create an array of pointers, okay, of the base class, okay, shapes, and we'll do 3 of them. Okay, so there's going to be 3 shapes we're going to store in here. We're going to store in this same array. We're going to store a triangle object. We're going to store a rectangle object. We're going to store a circle object. 3 different data types. Right? Triangle is its own data type, rectangle is its own data type, and circle is its own data type. Right? But because they are all children of the shape class, right, we can treat them as if they are the same. Okay? So let's do that. So this creates a array of pointers. So let's assign some objects to this array. All right, so we'll use an initialization list to do that. Okay. So what's an initialization list look like for an array of pointers with objects? Okay, just like this. We're going to invoke, where we talked about this, I think in chapter 14, we're going to invoke the constructors of each shape that we're interested in. Okay. So new circle. And we'll give it a name, circle, and we'll give it a radius 2.1. Alright, so that is the first object that's going to be added to our shapes array. And now let's do a rectangle. And we're going to give it a name, and we're going to give it a length and a width. And the name is rectangle. And the length and width, 3.1 and 1.2, whatever. Alright, and then finally, triangle. New triangle. Name the shape, triangle, give it a base, 8.1, and a height, 2.3. Okay, so let's put this on the home line so that way the code style is nice. Alright, so let's see if this compiles, make sure it works. Okay, now we have an array with those three objects in it. I'll comment this stuff out so we don't have to deal with it. Okay, we're only interested now in these three shapes in this array. Okay, so now since I have three different data types in the same array, well, guess what? I can now use a for loop just like I can with any other array and traverse the array. Okay, so for int I equals 0, I less than three shapes, I plus plus. Well, then what am I going to do? Well, in this for loop, I'm going to print all of the areas of all of the shapes inside this array. Or inside this array. Print area of all shape objects in this shape array. Okay, I think this is cool. So see out shape area equals this. Okay, so now I can do a shapes dot get area. Okay, so every time this cout runs, shapes here, it's not calling its get area function that's defined here because it's a pure virtual function. Okay, that wouldn't work. Okay, there's no definition for this. But what happens is that as this is invoked, right, dynamic binding cuts in, right, and C++ takes a look at the first object and says, oh, that's a circle. Well, it's time to bind this get area function to that circle object, and so this is the one it'll use. Okay, for the second object, it's going to use dynamic binding and bind get area to the rectangle object, and for the last one, it's going to use dynamic binding and bind get area to the triangle object. Okay, so let's check this out. Oops, hold on. What's my bug? Oh, silly me! I forgot. This is we're using pointers. This is an array of pointers. So dot notation is not what we want here. We want to use that arrow notation. I always forget that. All right, now let's try it. And it's an array, so let's not forget that. All right, there. Now I think everything should be squared away. There we go. Right. So, shape of the first, or the area of the first shape, which is a circle, 13.8544. The second shape, which is a rectangle, the area is 3.72, and the triangle area 9.315. All right, so that brings us to a close in this tutorial. We talked about creating classes. We used inheritance to derive child classes from the parent shape class. We made 3 different child classes. We used a virtual function in here that'll enable us to use dynamic binding to bind the correct get area function to each child class. And we used the class access specifiers here. We decided to use public, so that way the protected member variable from our parent class would stay private. Okay, once we inherited it, and finally we used polymorphism to assign different objects, 3 different objects, to the same array, and then we were able to use that array in a for loop to iterate over the array and invoke or call all of the individual get area functions using dynamic binding to print out the area. Okay, so I hope that you found this video helpful, and I hope that you'll be able to get started on the last homework assignment, and that it should be a breeze for you. So, as always, if you have any questions, shoot me an email or stop by my office hours. Okay? So, thanks for watching.